because, again, signal
Mm-hmm.
integrity was the new kid on the block, and it didn't really have any file formats. It didn't really have any nucleus of interaction in the industry. So we invented the IBIS Open Forum. And again, it's still there today, but that's why we say I was the father of IBIS.
Hi, everyone. It's Judy Warner. Welcome back to this week's Ecosystem Podcast. Today, I'm joined by signal integrity expert Don Telian of the SI Guys, or Signal Integrity Guys. Don has over 40 years experience in signal integrity and in fact is known as the Father of IBIS. He's going to tell us a little bit about how he and a group of collaborators launched that signal integrity model format during his days at Intel. We're also going to talk about a nifty cheat sheet, or an SI cheat sheet that he has that comes from his book, Signal Integrity in Practice. He really focused on the pragmatics of signal integrity, and I think you're going to learn a lot from Don today. Make sure you go check out the show notes. Everything we talked about will be down there, and I'm sure there'll be lots you'll want to tap into. Without further ado, let's jump into our conversation with Don Telian of the SI Guys. Hi, Don. Thanks so much for joining us today. I'm delighted to have you join as a first-timer to the podcast.
Judy, it's an honor. Thanks for having me.
Well, why don't we kick off by sharing with our audience a little bit about your professional background, and we'll start there.
Okay. Yeah, I've been doing signal integrity for 40 years, count them, 40 years, which is remarkable because we've only called it signal integrity for 35. But the first half of that, I was with the big boys, meaning Intel, Cadence, Hewlett-Packard, and for the second half, I've been a consultant, working for myself at SI Guys.
SI Guys. So let's talk about SI Guys. Tell us about your consultancy and what SI Guys or SI Guys is all about.
Yeah. You know, it's been a fascinating journey. Got to say, I love it. And basically, I just hop on the hardware design teams and I figure out where the problems are and help people win and succeed. And then I'm gone. And they say, "Who was that masked man?" Hopefully they send the check, but that's pretty much what I do. So that's been amazing because at this point I've been I don't know if chameleon's the right word, but I've just kind of learned how to fit into the hardware team and do what they need done, and then work with their layout team as appropriate to make sure they translate. You've got to translate signal integrity into layout or nothing happens.
Yeah, well, there's that.
Yeah.
I always say, you know, those chips sit on these little things called circuit boards, and that's where all the trouble happens these days, it seems like. So, well, I found you, Don, as you know, through our mutual friend, Eric Bogatin, and I heard you were on his podcast. For our audience, I'll share that link because I thought it was really good. And one of the things I learned about you and why I wanted to learn more about you is your interesting title that Eric gave you, which was the Father of IBIS. So can you tell us where that came from? And I'm sure there's a good story behind that.
Yeah. Thanks for that. Yeah. No, Eric didn't invent that. That has followed me around since 1992, for over 30 years. IBIS just celebrated 30 years. On my website, there's a picture of us cutting IBIS's birthday cake. So that in itself, I think, is pretty stunning. Like, what standard lives for more than 30 years and has, 25 member companies and so on. But most of the story is told on that podcast. Do you want me to give the abbreviated version here?
Yes, please. Yes.
Oh, marvelous. Well, we raised our hands at Intel. We were at Intel. I shouldn't say we. This is another distinction I have. I was the signal integrity group at Intel in 1989. There's probably hundreds now. But again, we were barely calling it signal integrity. So we raised our hands and said, we'll help design the PCI bus. And to do that, we had to invent this behavioral model thing. And the story is also told in my book right there, chapter 7.
Yep.
And I was given an unlimited amount of equipment and resources and college co-ops. And one of those was Arpad Marani, who invented this thing, this IBIS template, we called it. So anyways, we used that to design the PCI bus. Then we went on to design the interconnect around the first Pentium. And we had to give out models somehow for all that stuff. And there was no, giving out a silicon model was fraught with problems, right? Because of silicon process, right. Blah, blah, blah. And so we just bundled up our little template, and we had an Excel spreadsheet at the time that had VI curves, and we started giving out the models, and all the simulation vendors went wild. And they're like, well, let's standardize this thing. So we got 9 EDA companies to agree. And in 4 meetings, we resolved the 1.0 spec.
Wow. That must be a world record in any committee-oriented standard.
Yeah, it was, honestly, it was a lot of fun. And it went fast because it needed to happen. Because again, signal integrity was the new kid on the block, and it didn't really have any file formats. It didn't really have any nucleus of interaction in the industry. So we invented the IBIS Open Forum. And again, it's still there today, but that's why we say I was father of IBIS, but not kind of an absentee father, because they yanked me after those 4 meetings and put me on the next Pentium, or I don't know what it was. But it right. was that was a fun little blip in my career, and we went on to do more stuff after that, of course.
So, what is it about those IBIS models that have made them persist for 30 years, do you think?
Well, let's say what we mean by those IBIS models, because if you compare the 1.0 spec to the 7. Whatever, oh my gosh. Right. So it is, there's been guys like Michael Mermack, Mike Labonte, Bob Ross, who have carried the spec through generations and generations, and like we're going 10,000 times faster. So something had to change in the spec, right? So they've just of course they've taken the collaborative spirit we've started this thing with, and they've just kept that alive, so that the standard has input from all the right people, and the party's still happening. Great.
That's very fun. That's a very cool title to bear, and a great story. That's a neat little feather in your cap, I would say. So, the other thing that sort of put you on my radar was Signal Integrity hosted a webinar that I believe is sponsored by Cadence, in which you did a keynote. And let me see. Well, you'll have to remind me of what the name of that keynote was. But you shared in that talk an SI cheat sheet. So I thought, oh my gosh, our community needs to learn from you, hear about that, and tap in. So why don't you start out by telling us about that keynote, the things you covered, and then let's dive into what the heck your cheat sheet is.
Okay, that's great. That's 2 questions in one. I wish I had my little props with me, but I'll try to do it anyways. The talk was called S plus I, right? Signal integrity equals $. So it turns out if you put a I over an S, you get a $, which Rich Mellitz showed in one of his talks one day. I thought that was the funniest thing. So it's S plus I equals $, and it's how to succeed in a career in signal integrity.
Which I love that.
Yeah. I don't know if anyone's ever attempted that. And so now that I'm 40 years in, I hope I succeed, but I've been doing it for a little while. So that was really interesting in itself, to just talk about what it is we do and why we do it and how we do it and so on. But the thing you asked about that was in there that I think is of particular interest to your audience, Judy, is the so-called cheat sheet. And so if you don't already have a printout of this cheat sheet, you can get one on my website. You'll probably link it, right, Judy, in this podcast?
I will. I definitely will.
It's at the end of chapter 2 in the book here. And what it does, like, it was a gutsy move. Like, I don't think this has happened either. I said, let's just put on one page what everyone has to do. So, and at any data rate. And so one axis is data rate. And then it's kind of a cheat sheet. And it's also sort of a checklist. So people have printed that. They put that on their wall. They keep it in their back pocket. Because one of the things we have to do, even today, you might still get asked to do a 3 gigabit per second link, and so how do you switch your head from doing 32 to 3, right? And so things change. Things have changed. That's about 20 years of history. And so the cheat sheet has the columns to kind of orient you in time and space, data rate, and so on. And it's kind of, it's abbreviated, but it's helped people. So I'm happy about that.
Yeah, it seems like a quick reference guide, right?
Yeah.
And what I also noticed about that is it referenced pages in your book, but I want to talk about that as a separate point. So can you share like a few points that we can maybe give our audience some few takeaways? And then, like you said, I'll make sure we click back to your website where they can download it themselves.
Yeah, absolutely. I think one of the biggest things, and in fact, this is at the top of the cheat sheet, as you move faster and faster, of course, your edge rates get faster and faster, right? But then people fuzz out and they go, wait, picoseconds, and I don't live in a picosecond world, so there's a chapter in my book that translates that into a feature size, meaning a dimension on your PCB. Okay.
Okay.
So, around 6 gigabits per second, all of a sudden, the length of a via in a normal PCB became something you had to think about. Okay. Now, thinking about it means that that edge rate at that data rate is going to see that feature. Okay.
Okay.
So in other words, you got electrons running from the transmitter to the receiver, and they encounter these, we might call them speed bumps along the way. Okay. And that changes with how fast your edge is. So anyways, if you have a very fast edge, you see more things along your way to the receiver. And so how big a feature is this electron going to see? And it doesn't just see it, it responds to it. If its impedance is different, it bounces off. It goes, oh my goodness, I didn't sign up for this. I'm on 100 ohm interconnect. This thing is 40. What's going on? And so it starts bouncing off and reflecting around and basically messing up signal integrity. So that's a very key line where I give the dimension of the relevant feature size. So basically, if you have a connector pad or a via that is larger than the relevant feature size, then you need to match the impedance of that feature. Did any of that make sense?
Yeah, it totally did. And I love that. Okay. So that's the first one. You got another goodie for us?
Oh, absolutely. I'm glancing over on the side here. There's about 12 things over there.
I know. I'm not going to ask you to tell us all, but...
Well, like it tells you at one point you switch from 45 degrees to curvy routing. And if anyone wants to debate that, I give the chapters in my book, and you can read about that. You could still debate it. I think another interesting thing, and this sort of dovetails into the feature size. There's two more things that you really got to watch out for, and one is the stub length. Stubs. Yeah, stubs. And there's stubs hiding in places. Like, let's say you have a connector pad here, and you have a, can I even do this? Let's say you have a finger coming down onto that connector pad. Well, out here is a stub at certain frequencies. I'm like, oh my goodness.
Okay, not a via stub.
No, just the connector pad. Like, they're trying to get this solder joint. I got it. Right. So if this thing misses and comes over here, all of a sudden I have this. So I have an article in Signal Integrity Journal, like, oh no, stubs, where are they and what are they? So anyways, the length of a relevant stub, Eric Bogatin defined that long ago, but you have to keep an eye on that at different frequencies. And then, of course, the amount of loss that you're allowed to, insertion loss that you're allowed to have between transmitter and receiver is a number that keeps getting larger and larger with data rate. Okay, and that's because equalization keeps getting better and better with data rate, and because you can't avoid it. But there was a time around Gen 4 or in the tens of gigabit per seconds when discontinuities ruled the day, and that's what was making systems fail. Okay. Right. Now we're up in the 30 dB of loss range, and oh my gosh, now loss is starting to come back and somewhat rule the day again. But we can do this. It's okay. And if you notice, listening to me talk, sorry, I'm all over the place this morning.
No, it's good.
I keep talking about transmitter and receiver because one of the things I assert in my book is signal integrity has become serial. Okay. And so I'm not trying to ignore the famous DDR, right, which is a tremendously complex deal. But as your hardware engineers know, most of their designs, they're cutting and pasting that these days because it's so tremendously complex.
That's interesting. Okay, I have a follow-up question for you. So forever there's been this debate over right angles versus curvy lines on traces. Okay, you clearly stand in the curvy trace line. Can you, without us going way far down the rabbit hole, can you give us an idea of the conclusion you've come to as an SI expert?
Yeah, I don't think it's complicated. And on my website and in all my reports for customers, I always link this particular article. And I think Eric's on that one. Sorry, I'm fuzzy on that again.
That's okay.
It simply shows.
I'll get it.
It simply shows how much extra metal is there if you make a 90 or you make a 45. And so in a world where 9 mils of stuff is starting to become relevant, just think about that extra metal trying to go around the edge. So I'm not necessarily a fan or not a fan, but I do get to watch a lot of designs. I'm involved in dozens of designs, and right around 16 gigabits per second, we switch to curvy.
Okay, good to know, because this debate has been going on forever, and I was in RF for quite a while, and everything's curvy on those boards, and then there's people like, we debunked that 15 years ago, and I'm just in the middle going, okay, I believe you. I'm not an engineer, but it's really interesting, this debate, so I thought I'd try to pull that out of you.
Well, my tagline on my business, sorry.
No, go ahead.
My tagline on my business is real data, no nonsense. And so
I love that.
Anyone who reads my book, it's just a lot of pragmatism, really, and so I I don't get emotional or heated or real in the middle of those shall we call them religious debates because we got to get product out the door, right? I mean, we gotta stay on schedule.
Yeah. So it's not so much about ego, like what works and how do we get it out the door as fast as possible. Yeah, makes sense to me. Okay, now I want to circle back, if we can, Dawn, to your book. Now, let's see, Signal, Integrity, and Practice. Even the title is pragmatic. I like it. So we know your cheat sheet's in there, but as you know, there's been many a book written about signal integrity. Why did you choose? Well, when did you write it, and why did you write it?
Oh, I've written it over the last few years, and like Eric Bogatin says in his review, like this is the book that tells you the stuff the textbooks don't tell you.
Okay.
And so I thought, gee, Eric, I wish I had invented that. I mean, that sort of sums it up, because there's like maybe one or two equations in the book. It's not your textbook per se, but it is about the practice. Okay. Because every day, I mean, some people could tell you there's this process for doing signal integrity, and I'm even one of them, but every day it feels like I'm inventing it afresh. Like, what's really relevant in this design? Where is the problem? How do we get in, get out, not waste our time, do enough, but not too much, So this is where there's a fair amount of, Eric called it nuance. I'll just call it skill, experience. There's some stuff you need to know that, unfortunately, the tools won't tell you. Tools are tools, right? My hammer won't build my table. Okay. So tools are tools, and they're fantastic. Don't get me wrong. But I can do a lot of good with my hammer, and I can do a lot of mess with my hammer. I can waste time with my hammer, right? Or I can be productive.
Right.
So I guess I like to think what's happening in here is, here's the other side that maybe no one's telling you. I mean, why write another textbook? They're great. There's so many out there. They're really good.
Mm-hmm.
So, but here's the other side. I hear it's really easy to read. One of the reviewers on Amazon likens it to the Feynman lectures, which maybe were entertaining. I'm not sure what he meant by that. But I don't know. I mean, those in my family say they don't understand what's going on there, but I think engineers, particularly hardware engineers, will pick it up and go, "Oh, this makes sense. Like this is no nonsense."
Well, and it sounds like your focus on how do I solve this problem? And of course there's all this math, and of course there are all these tools, but here's where to look, and here's the usual suspects, and here's how to fix it, like in practice, right? Perfect title.
Yeah. Go ahead.
With the focus, with the end in mind, like old Wayne Dyer used to say, begin with the end in mind, right? So the goal is to get a functional, reliable electronic system out the door.
Yeah, and I mean, as a consultant, that's what gets me paid. So maybe that helps me focus there. But I don't get paid just to sit in here in the morning. Okay, I don't get paid for showing up. I have to produce something, and so that's that maybe helps keep me on task. I don't know.
Keeps you honest. Okay, well, we will definitely share that. And I really like how you've unpacked, that it's signal integrity and you nailed the title, I think, along with the things you said, is plenty of textbooks have been written. So between your, which is a big reason I wanted to share you with our audience, is all of your knowledge yet, but you've baked it down into really practical ways to apply it and succeed, which everybody who's listening or watching wants that, Right. It's with the speeds and complexities we're working with, it's Al Neves says it particularly as you get into the higher speeds, he goes at 56 gigs, everything matters. Everything, and things that, we didn't think matter, they all matter.
Well, thanks for that. I hope it's helpful. I mean, I don't want to overpromise, but this is the goal. I'm at this stage in my career where, it's I don't want to sound phony, but I think it's really relevant to get the next generation spun up and succeeding,
No.
because
I think we all share that at this stage, like time to pass ye old baton. And so people like you passing that on is, I think, so valuable. And whenever I've worked for a while, when I was at Altium, I worked with tons of EEs, but they were all younger. They were the up and comers, right? And learning so much. And I always try to say, so much has been baked into your EDA tools and stuff, but everything you're doing today, we're standing on the shoulders of the Eric Bogatins, Don Telians, and, and to be able to recover like what you learned along the way and pass it around, I think, or pass it along, I think is really critical. So I appreciate that.
Thank you.
Now when I did my previous podcast, I used to do something called Engineers After Hours. And besides a really talented, gifted engineer with lots of years of experience and learning through life and hard knocks, you have a couple really interesting side hobbies and interests. So why don't you tell us about that?
Like, you mean counting the stars or painting bedrooms, or which one do you want to know
let's
about?
just start with the drums. Let's just start with the drums.
Yeah. In fact, there's only a djembe in this room here. Sorry about that. But I was a pro drummer before I went into engineering. And so I still kind of do that.
Like when you say pro drummer, like in what context?
Oh,
like what kind of things did you do?
Well, I mean, come on, it was the 70s and 80s. I mean, this is when music was music.
You and I
right?
are from the same era. That is like the real when they actually made music. Do I sound old and bitter? Just a little.
So I was in the Bay Area, the San Francisco Bay Area, and so I played all around there. We would put on tuxes and play classy music, or we would play really loud or Latin or whatever. And I had 80 students at the music shop. And I made a living at it.
Wow.
And so that's a fun diversion, And now I live up in the Sierra Nevada, and so I play around the Yosemite area, and started teaching again, but not doing that right now.
Well, you and I were emailing back and forth, and it cracked me up because you said, oh, yeah, I was up at Bass Lake because you knew I'd just been there on vacation. And you said I'd been training there. And I'm like, who would want to learn signal integrity at Bass Lake? I was really confused. And so I asked you, what kind of training you're doing? So tell our audience what kind of training you were actually doing.
Okay, I will. But some people do want to do trainings at Bass, signal integrity trainings. I've hosted a couple of the big companies.
Really?
Both at Yosemite and at Bass Lake to come up and do offsites. So if your company is thinking about an offsite, we can even train that. But no, I was training for triathlon, which is a bunch of crazy people who race. They jump in water, they swim for a while, then they're dripping wet, and they ride a bike, maybe 18 miles an hour for so far, and then they jump off the bike and they run, and then you go, what? And everyone claps.
Yeah.
So that, but
Don Telian what?
The lesson for the engineers listening. So listen to me, guys and gals. It took me 30 years to learn that sitting at a desk is very difficult on the body. Huh? So make yourself get out there and move. And so in my 50s, I started doing this triathlon stuff with my daughter, who's a national champ, by the way. And that rescued me from a lot of atrophy, a lot of health problems, and so on and so forth. So that's the takeaway there. Engineers,
well, I love that.
Get up and move.
Yeah. Well, and to, put my own little story in there. When COVID hit, I had been ignoring my health, eating whatever I wanted, sitting at a desk all day, and aging badly, I think, physically. And when COVID hit, I just decided I have time to eat right and exercise. So I started walking till I got up to 5 miles a day. And I thought that would be good for my knees because I had one sort of bad knee that hurt me sometimes. So I did, and I lost 35 pounds and I got healthy and everything works better. I need some muscle now though. So you've really made me feel like a slack. Thanks, Dawn.
Well, that wasn't my intention.
I feel like a slacker after you. No, I know. No, it's actually inspiring. It's actually very inspiring. So what fun hobbies, and what an interesting life you've led, Dawn. Thank you so much for everything you do, for letting our audience get a chance to meet you and learn from you and hopefully connect with you on LinkedIn or somewhere else. We really appreciate coming on and sharing all your great knowledge and the interesting things you do.
Well, again, Judy, it's an honor. And I'd encourage your listeners, do reach out. I actually do respond. And again, I'm at that stage in my career where, it's... I mean, Judy, I've worked out of my home office since 1996. So it's kind of fun to see real people now and then and talk and relate. So all the best to all of you in your careers, and thanks for what you're doing, Judy.
My pleasure. Dawn, will we see you? I forgot what you told me. Will we see you at DesignCon?
Maybe not this year. Pretty sure not this year.
Sad.
Pretty sure not this year.
Okay.
Every other year at least.
Okay. Well.
So.
Okay. Well.
I wish I could tell you.
Maybe we'll hit you next year.
Yeah, 2025.
Okay. Sounds good. Well, to our listeners, I trust that you've enjoyed this conversation and learning from the father of IBIS, who runs triathlons, plays drums, and writes books. Other than that, he's not that busy, besides having a huge family. But I hope you've enjoyed getting to know Dawn as I have. Please go check out the show notes because everything we've talked about, I will put there, as well as Dawn's LinkedIn profile. So make sure to connect and go look for his cheat sheet and his book, and I'm sure that will benefit your career. We will see you next week. Until then, remember to first subscribe, and connect with me on LinkedIn and all the usual places, or also become part of our engineering community at thedoubleecosystem.com. We'll see you next week. Until then, remember to always stay connected to the ecosystem.